Hi everyone, this is a first online lecture video on computer and ICT at Paradise Business and Technology College 2026 online class. I am the class coordinator, Mr. John Cooper. The duration of the course is 4 weeks. This is my qualification and work experience. I have a bachelor degree in physics, electronics instrumentation from PNG University of Technology. I also have level 2 training and assessment. I also have class PNG training authorization number when I was with Architect PNG. I'm also a AutoCAD trainer. I attend OHS level 1, and when I was with Paradise Foods for part-time, I also attended a safety induction training there. My work experience, I was a lecturer at Asia Pacific at OLA, opposite PNG Power Aviation Department. I instructor and lecturer at Architect Aviation College, electrical maintenance engineer at Atlas Steel PNG. I was an electrical instructor at Don Bosco Technological Institute, Port Moresby. I was an electrical supervisor with Pacific Industry. I also with one of the local company, Green Dot Energy, and I was part-time shutdown technician at Paradise Food PNG. That was in 2021. So these are my qualification and experience. Okay, this is our course outline. All the units on the other column and the duration and assessment on the other column, plus the marks, the votings of each quiz. So we have 14 units. The first one is understanding the computer organization architecture is the second unit. Unit 3 is memory and storage system. Unit 4, input devices. Unit 5, output devices. Unit 6, computer codes. Unit 7, computer arithmetic. Unit 8, logic circuits. Unit 9, computer software. Unit 10, operating systems. Unit 11, Microsoft Office. Unit 12, programming languages. Unit 13, data communication networks of computers. Unit 14, the internet and World Wide Web. So after each unit, we are expected to do a quiz. It may be 15 to 25 marks quiz, and then we proceed to the new next unit. So the final exam will cover all the units, and it will be 100. It should be 50 to 100 marks. Okay, in this video we are going to look at the first unit, understanding the computer. Okay, that's chapter 1, understanding the computer. Chapter objectives. In this chapter we will learn how computers receive, store and process data to generate useful information, the improvements in functioning of computers in the last few decades, the 5 generation of computers, how to classify computers on the basis of operating principle, application and size. The computer system as a combination of hardware, software, data and people. And we are also going to learn about the use of computers in different fields. So this is our learning. These are the learning objectives that will guide us in this first chapter. Okay, these are the topics under chapter 1 or unit 1, understanding computers. The first is introduction, evolution of computers, manual computing devices, automatic computing devices. We are going to look at generation of computers, first generation of computers, second generation, third, fourth, fifth generation of computers. We are going to classify computers based on operating principle, based on application, based on size and capability. We're also going to look at the computer system, which is made of hardware, software, data and people. Lastly, we are going to look at how computers were computing concept. Okay, what is a computer? A computer is an electronic machine that takes in input, which is data, programs, and user response, or what we give to the computer. It processes it and produces useful output, which is information. It is often called a data processing system because its main function is to process information efficiently. So computer basically takes in input, processes it, and gives output. And in between, memory comes into play for storage and all this. So you can look at the diagram there. This diagram is called a von Neumann architecture. We are going to come to that diagram later on, but this is how a computer operates: input, processing, storage, and example of computers. Example of computers ranges from personal devices like laptops, desktops, and smartphones to powerful systems like servers, mainframes, and supercomputers. They are versatile machines including tablets, wearable technologies like smartwatches, and embedded systems in cars or appliances designed to process data and perform specific tasks. So computers can be desktop computer, laptop, notebook, hybrid computer, tablet, smartphones, anything that takes in data, processes it, and gives out output. So mobile phones, computer, these are all computers. And Air Force ATM, these are all computers. Anything that takes in input and gives out output. Computers are widely used to their important computers are widely used due to the important characteristics including speed. Talks about how fast the computer performs tasks, whether it's very quickly or slow. Storage capacity is one of the important characteristics of a computer, whether it stores large or small amounts of data. Accuracy of computer produces precise results. Okay, computer its accuracy is one of the very important characteristics. We have reliability. It gives consistent and dependable outputs. Versatility, or it performs many different tasks at the same time. Multitasking, we can say multitasking or versatility. Diligence, works continuously without fatigue. The computer does not fatigue or rest. If it continues to work and work and work, so that's diligence. Computer works continuously without fatigue. However, computers have limitations. These are the limitations of computers. They depend, or otherwise we can say the downside, disadvantage of computers. They depend on correct input and instruction. If we give wrong input, then the computer will give a wrong output. So computer depend entirely on instruction and input that we give to them. So this is one of the downside. They lack common sense and cannot think independently. Computers are not human beings, so they don't have common sense. They cannot make a decision involving human judgment or qualitative factors because they are not human. So these are some of the downsides of computer. Evolution of computers. The evolution of computers began in ancient times when people used simple machines like fingers, stones, sticks, and ropes to perform basic calculations. These methods were slow and less accurate, leading to development of more advanced computing devices. So previously they used manual computing devices. Okay, so these are early stage of early computers use. Example of manual computing devices. Manual computing devices were the first major step in the evolution and development of computers. Early tools like the cent table and abacus help in basic arithmetic, so basic addition, subtraction, multiplication. All this is done by the manual computing device. More advanced devices such as Napier's bones, slide rule, Pascal line, and step reckoner improve calculation, especially for multiplication and division. So on the other side, you see these are the early computers used at that time. So computers comes from the base word compute. Compute mean calculate. So one of the very functions of computer is calculation. Automated computing devices. The development of automated computing began with Charles Babbage, who is known as the father of modern computers. In the early 1800s, he designed a difference engine to automate mathematical calculations and later developed the analytical engine, which introduced key features of modern computers such as input, output, memory, processor, and control unit. Although advanced for its time, it was slow. So that was the first automated computer after the manual computing devices. It was a bit advanced at that time than previous manual computing devices, but it was slow. But it has all the features of these modern computers that now that we are using: the input, output, memory, processor, and control unit. So that was the first automated computing devices developed by Charles Babbage. So that's why they say he's the father of the modern computers. In 1944, Howard Aiken developed the Mark I, which was faster than Babbage's machine but still large, noisy, and relatively slow in output. Okay, so that's the Mark I computer there. Around the same time, Alan Matheson, that was in the same year, Matheson Thury contributed to computing with the Colossus, the first electronic digital programmable computer. It used vacuum tubes but was designed for specific tasks only. In 1946, the ENIAC, Electronic Numerical Integrator and Computer, developed by J. Prespa Hickett and John Maudsley, became the first general-purpose electronic computer. It was very large but much faster than earlier machines and could perform complex instructions. So as time goes on, the new invention tends to be more faster than the previous invention. So these are the two blokes there, John Maudsley, J. Prespa Hickett. They invented electronic numerical integrator and computer. That's ENIAC computer in 1946. It's almost the year before World War II. World War II began in 1948 or 1942. Yeah. The ADVEC electronic discrete variable automatic control computer was invented in 1949, also by Hickett and Mosley. Introduced the stored program concept using binary numbers to store both data and instructions in memory, an important step toward modern computing. So previously, manual computers, they don't have storage, but as time goes on, the computers invented, they start to have memory. So that machine there, ADVEC, developed by Prespa and Mosley, add the memory to store information. Another early computer, the HEADSEC, developed by Maurice Weeks, used vacuum tubes and could process about 650 instructions per second, though it was still relatively slow. So that's another computer invented by Weeks, Maurice Weeks. It still uses vacuum tubes. So these are first generation of computers that use vacuum tubes. Later, when we come to generation of computers and their main component, you will see Finally, in 1951, the first commercial computer, UNIVAC, Universal Automated Computer, was developed by Eckert and Maudsley. It could process both numbers and text and introduced the separation of input, output, and processing functions. Okay, these are the basic history of computer. Now let's look at the generation of computers. Computers have evolved, meaning changing from one form, developed from one type of computer to another as time goes on. So computers have evolved through 5 generations, each representing major improvements in technology, size, speed, and cost, and also performance. These developments include both hardware and software advancements. So we have first generation of computer, second, third, fourth, and fifth generation of computers. First generation of computer was invented and used between the 1940 to 1956. The main components of these computers are vacuum tubes. These are vacuum tubes, as you can see from the this idea. These are vacuum tubes, and these are the first generation of computers that are made of vacuum tubes. They are very large, expensive, and generated a lot of heat, because vacuum tubes, they use a lot of power and they heat up. They use machine language and punch cards. Examples are ENIAC, EDIVAC, and UNIVAC. Those computers developed by Presby and Maudsley. Limitation or downside of these computers: they are very bulk, they are unreliable, they are single tasking. They perform one instruction at a time, and they are difficult to program. So this is the first generation of computer. They are made up of vacuum tubes, which means to say that memory and all the hardware components of these computers were made up of vacuum tubes. The second generation of computers was invented and used between the year of 1956 and 1963. The main components of these computers are transistors. These are transistors. Transistors are like a device on any electronic circuit board. You see something like this one. They are transistors: collector, emitter, and base. There are 3 legs: collector, emitter, and base. These computers are smaller, faster, cheaper, and more reliable than the first generation. In this second generation of computer, we have introduction of assembly language. Examples are IBM 1401, IBM 7090 or 7090. Limitation or downside of this computer is still expensive, required air conditioning, limited input and output improvements. So because they're very big, they are very expensive. So these computers were owned by only big organizations and the government, the first and the second generation of computers, because it's very huge and expensive. So small companies and individuals cannot afford to buy these computers. And because it's very large, it uses a lot of power and it heats up. So that's why we need that computer to be placed in an air conditioning room to cool off and function properly. Third generation of computers was in the era of 1964 to 1975. That's when we gained our independence. It used integrated circuits. Integrated circuits, you see something like this one on the computer. When I want to explain integrated circuits to my students, I used to refer them as they are like millipedes on the circuit board. Millipedes, you know what the millipedes are? They have a lot of legs, or ICs. They are like millipedes because they have a lot of legs here. That's how simple I explain to my students. So these are ICs, integrated circuits, meaning one or more circuits are integrated into one IC chip. Because ICs are very small, all circuits are integrated into one small component. The size of the computer is reduced. So the computer was much smaller, faster, and more efficient. It introduced high-level programming languages, could handle multiple applications, and it's general purpose. It's not we have different types of computer, general purpose and specific special purpose. So it was a general purpose computer, third generation. The limitation or downside or disadvantage, it was still expensive, high cost, limited storage, and required cooling. Okay, still age up. Okay, fourth generation of computer use microprocessor, LSI and VLSI technology stands for large scale integration and very large scale integration technology. They use microprocessor. You see this one here, this is an example of microprocessor or CPU, the same thing. The development of personal computers was during that era. It uses GUIs. GUI stands for graphic user interface, better storage and networking. LAN, local area and wide area network were introduced, were used at that time. Computers were connected in a network, so computers can communicate. That is in the fourth generation era, between 1975 and 1989. The downside of this computer limitation or disadvantage, it's complex because it uses a microprocessor. We have complex chip manufacturing, still dependent on user instruction. Okay, so these are some downside of fourth generation of computer. Fifth generation, okay, it is based on ultra large scale integration technology, ULSI, includes modern computers, laptops, mobile devices. Features of this fifth generation of computer: very high speed, large storage, multitasking, multimedia. Okay, so this is the era in which we are in now. Development of AI, parallel processing or multitasking, internet and advanced systems. Limitation of this computer, still like human full-like intelligence. So computers are very fast, they are very effective, but they still cannot think and act like humans. So these are downside of computers even to now. So these are 5 generations of computers. So computers have evolved from one form to another until now. What we are seeing is we are in the AI era. So let's continue. Now let's look at the classification of computers. Computers can be classified into 3 main categories based on operating principle, application, and size or capability. So classification of computer based on application, we have analog computers, digital computers, and hybrid computer. Based on purpose, we have general purpose computer and special purpose computer. Based on size, we have supercomputers, mainframe computer, mini computer, workstation, and microcomputer. So computer can be classified into 3 different categories based on application, purpose or use of the computer, and size of the computer. Okay, classification of computer based on operating principles. We have analog computer. Analog computer deals with analog signals, processes continuous data, electrical signals, very fast but less accurate, used in scientific and engineering application. We have digital computer, process and deal with binary or digital signals, ones and zeros. Hybrid computers, computers that process and deal, store and process information both in analog and digital signals. So these are the classification of computer based on principles. Analog computers like speedometer used to detect the speed of vehicle. You will see in developed countries they use this one to detect the speed of vehicles. We have thermometer. Thermometer is also a computer. We have digital computer, desktop computer, or personal computer, laptop, hybrid computers, analog plus digital. So digital receive and perform and store data in digital signal or digital form. Analog uses analog signal. Based on application, classification of computer based on application, we have general purpose computer. They are versatile machines that can perform many tasks but may be slower for specific jobs. We also have special purpose computer designed for a specific task, faster and more efficient, like the Air Force machines are more specific computer. Okay, based on size and capability, we have microcomputer, mini computers, mainframe, and supercomputers. Microcomputers, small, inexpensive computers for individual, example desktop, laptop, and NL devices. Mini computer, medium-sized system that support multi-users used in small to medium business. Mainframe computer, large powerful system used by big organization processing huge amount of data and supporting many users, like they use in mining for process control, they use in industrial setting. Supercomputers are used by NASA and all this organization, very big organization. Supercomputers are fast and most powerful computers used for complex scientific calculation like weather forecasting and research. NASA or weather stations, they use these supercomputers. So based on capability, we have micro, mini, mainframe, and supercomputers. Classification of computer based on purpose and size. We have general purpose. We have these super, mainframe, mini, and microcomputers, general purpose and special purpose. So this is what we have discussed already. Computing concept. Let's look at computing concept. Computing concept explain how a computer works through the input to processing to output, or IPO cycle. Input, the computer accepts raw data from the user. Well, that's when the user gives in input data or instruction using input devices like keyboard and mouse. Processing, the CPU, central processing unit, brain of the computer, process the data using program instruction to convert it into meaningful information. Storage, the processed data is stored in memory, main memory, or external storage for future use. And then we have the output. The final information is delivered to the user through output devices such as monitor and printers. So this is the computing concept: input, processing, storage, and output. Okay, this is the block diagram of the computing concept. We have input is given to the computer through the input devices by users, and that's the raw data given by users to the computer to process, and then the computer takes it and process it using the CPU, process the raw data, and the processed data is stored in the memory, and then it's also presented to the user through the output devices. So this is the basic computing concept in a block diagram. This computing cycle or computing concept can be represented by this diagram also. It's called a von Neumann architecture. It depicts the overall flow of the computing concept from input to CPU, processing, storage, memory, and then we have the output. So in the CPU we have other components in there. In the CPU, like control unit, we have logic unit, and we have register, arithmetic unit, and all this in the central processing unit. Later, when we come to computer architecture and organization, we're going to look at each of the units in the central processing unit. But for now, for computing concept, we have input, processing, storage, and output. Okay, the computer system. A computer system consists of four main components that work together: the hardware, software, data, and the people or the user. These four components makes up the computer system. Hardware, anything that is physical, the keyboard, the monitor or screen, or the input-output devices, the physical parts of a computer, such as keyboard, mouse, CPU, memory, monitor, and printer, responsible for input, processing, storage, and output. CPU is the main unit with ALU, arithmetic logic unit. ALU stands for arithmetic logic unit, performs arithmetic and logical operation. And then we have CU, control and manages all instruction. Control unit, CU stands for control unit in the CPU. We have software, programs and instruction that makes the computer work. We have two types of software. We have application software and system software. Application software used by user for specific tasks. Example, word processing, spreadsheet. These are application software. System software control hardware and support application. Examples, operating systems, okay, or compilers. Okay, so these are examples of operating systems. Raw facts entered into the computer to produce information is a data. Okay, so there can be two types of data. We have qualitative data, text, image, audio, video. Quantitative data, numbers and symbols, stored in binary form, bits and bytes, ones and zeros. Okay, the last component is user. A computer must have user, otherwise that computer will not be useful. So we have individuals who design, develop, and use computer systems, include system professional, engineers, programmers, and users in business, education, etc. So users of computers. So these four components or four parts makes up a computer system: hardware, software, data, and user. Application of computers. Computers are widely used in almost every area of life due to their speed, accuracy, and large storage capacity. They have reduced paperwork and improved communication and efficiency. Major applications: they are used in education, used for teaching, online learning, like what we are doing, research, exams, and presentation. In business, help store data, manage database, conduct online transaction, and all virtual meetings. Any meeting that is conducted online is called a virtual meeting. Like our class here is called a virtual class or virtual learning. Communication enables data sharing through the internet, email, and other online platforms. This is one of the applications of computers. In science, computers are used for research, data analysis, and predicting natural disaster. Like engineering, assists in designing, drawing, and complex calculation like AutoCAD, SketchUp, all these application. Entertainment, used for creating graphics, animation, and media content. Banking, support online banking, money transfer, and bill payments. Health, helps in diagnosing diseases, monitoring patients, managing records, and telemedicines. Used in departments like census, defense, and administration in government or e-governance. Okay, some important terms to remember in this chapter. We have computer. Computer is an electronic machine that takes in input from the user and store and process it to generate the output in the form of useful information to the user. Data, the raw details that need to be processed to generate some useful information. Program, the set of instructions that can be executed by the computer in sequential or non-sequential manner. Information, process data. So there's a difference between information and data. Data, raw data. Information, process data, useful for user. So CPU Our central processing unit is the processor or the brain of the computer that's responsible for controlling and executing instruction. Monitor, the screen of the computer, which displays the information in the visual form after receiving the video signal from the computer. Transistor are three-legged device, a semiconductor device that is used to increase the power of the incoming signal by preserving the shape of the original signal. This transistor is a device that is used to make the second generation of computer. They were mainly made up of transistors. Second generation. Microprocessor is an integrated circuit that contains the entire central processing unit of a computer and on a single chip. Vacuum tube. This is that's the main component of the first generation of computer. Is an electronic tube from which all or most of the gas have been removed, permitting electron to move with low interaction with any remaining gas molecules. So vacuum tubes were used in first generation of computer. LSI, large-scale integration. VLSI, very large-scale integration technology, refers to IC or technology with many devices on one chip. So these were the technology used in fourth and fifth generation. ULSI, ultra large-scale integration, used in fifth generation of computer. IC, the circuit that combine various electronic components such as transistor, resistor, capacitor, etc. on a single small silicon chip. So integrated circuits, ICs. Analog computer, a type of computer which represent data in the form of continuous signal. Analog signal. We have digital computer, a type of computer that store and process data in digital form and is also known as the digital information processing. Hybrid computer, a combination of analog and digital computer because it encompasses the best features of both of these computers. Microcomputer, a small digital computer that is designed to be used by individuals like mobile phone, palm top, or whatever it is. Supercomputers, the fastest type of computer that can perform complex instruction at a very high speed. Mainframe computer, a very large computer that is employed by large business organizations for handling major applications such as financial transaction, processing application, and ERP. Okay, like ones used in mining and banks are mainframe computers. Hardware are a group of electronic devices that makes up a computer. They are used for performing tasks such as entering the data, processing the data, and then displaying the output to the user. Software, the programs and instructions that help the computer in carrying out their processing. Okay, software like Microsoft Word, Facebook, photo editor, anything that is virtual, not physical. It's in the computer in the forms of programs are called software. There are two types of software. We have application software, the programs which are designed to perform a specific task for the user. And then system software, the program which are designed to control the system operation of a computer system, like operating software. So basically, operating systems or system software provides the platform for application software. Without system software, the computer is blank, and with system software, the computer is functional, and you can install application software onto system software. So system software provides the foundation for application software. Okay, that brings us to the end of chapter 1 or unit 1 presentation. We will try to see if we will have a short quiz on this chapter 1, but I'll let you know. Thank you. Any questions, you can post it in the comment below.